Microscopic Interpretation of Chemistry.
Learning objectives recognize the microscopic perspective, identify the examples of microscopic, examine the relationship between microscopic and chemistry, and classify the microscopic properties. The study of chemistry. The study of chemistry involves three levels of understanding or three perspectives: macroscopic, microscopic, and symbolic. But for today's discussion, we're going to focus on microscopic interpretation of chemistry. First is what we have to define what is microscopic. So microscopic, micro comes from Greek and means small, too small to be seen even with standard microscopes and often must be pictured in the mind. What is chemistry? Chemistry is a science based on observation and experimentation.
The microscopic domain of chemistry is almost always visited in the imagination. Micro also comes from Greek and means small. Some aspects of the microscopic domains are visible through a microscope, such as magnified image of graphite or bacteria. For example, in virus, viruses are too small to be seen with the naked eye. But when we're suffering from a cold, we're reminded of how real they are. Molecules into tissues and energy, and the evolution of heat as bonds that holds atoms together are created. The physical properties of matter can be viewed from either the macroscopic and microscopic level. The macroscopic level includes anything seen with the naked eye, and the microscopic level includes atoms and molecules, things not seen with the naked eye. Both levels describe matter. Matter is anything that occupies space and has mass and can be in three states, which is solid, liquid, or gas. The chemistry deals with the composition, structure, and properties of matter, and the ways by which various forms of matter may interconverted. Thus, it occupies a central place in the study and practice of science and technology. Chemists use the scientific method to perform experiments, pose hypotheses, and formulate laws and develop theories so that they can better understand the behavior of the natural world. To do so, they operate in the macroscopic, microscopic, and symbolic domains, but we are focusing in microscopic interpretation of chemistry. The chemists measure, analyze, purify, and synthesize a wide variety of substances that are important to our lives.
Microscopic properties. Its definition are the properties of the constituents of bulk matter, visibility, and visible to naked eye, unit of measurement, in a scale that is invisible to naked eye, which includes milli, micro, nano, pico, and etc. Examples: intermolecular forces, chemical bonding, atomicity, and etc. The properties considered in the microscopic thermodynamics include the properties of atoms that are on a very small scale. For example, intermolecular forces, chemical bonding, atomicity, and etc. On the microscopic level, a chemical reaction involves transformation of reactants atoms, ions, and or molecules into product atoms, ions and or molecules. This requires that some bonds be broken, other bonds be formed. Some nuclei be moved to new locations. There are a limited number of categories into which such microscopic transformations can be classified, and each of these can be related to a microscopic rate law. Therefore, studies of Reaction rates provide some insight into what the atoms and molecules of reactants and products are doing as a reaction occurs.
The microscopic perspectives: gas, liquid, solid. Solid. Solid is a particles maintain a regular ordered structure, maintains size and shape. Liquid is a particles remain close but no longer ordered, takes shape of container. Gas is a particles are widely separated and move independently of one another, fills available volume of container.
Go.
For example, by matter in bulk, we mean matter in a quantity to be seen, touch, or weigh. At a given temperature and pressure, a substance is either a solid, liquid, or gas. Other components of microscopic domain include ions and electrons, protons and neutrons, and chemical bonds, each of which is far too small to see. This domain includes the individual metal atoms in a wire, the ions that compose a salt crystal, the changes in individual molecules that result in a color change, the conversion of nutrient molecules into tissue and energy, and the evolution of heat as bands that hold atoms together are created.
The microscopic perspectives: non-binding intermolecular, ion dipole, ion charge, dipole charge, H bond, polar bond to H dipole charge, dipole-dipole, dipole charges, ion induced dipole, ion charge polarized E cloud, dipole induced dipole, dipole charge polarized E cloud, dispersion London, polarized E clouds. In structure number 1, ion bonding electron transferred from Na to calcium. Second structure is the covalent bonding atom share electrons. The third is metallic bonding ion surrounded by free electrons. And then the last one is the molecular bonding weak electrical attraction binds molecule. This figure 4. The letter A figure is the moisturized in the air iceberg, and the ocean represents water in the macroscopic domain. In letter B structure or figure, at the molecular level microscopic domain, gas molecules are far apart and disorganized. Solid water molecules are close together and organized, and liquid molecules are close together and disorganized. In letter C, figure, the formula H2O symbolizes water, and G and S and I symbolizes it phases. Note that clouds are actually comprised of either very small liquid water droplets or solid water crystals. Gaseous water in our atmosphere is not visible to the naked eye, although it may be sensed as humidity.